right, I think we're live. We'll hit that button and unmute Kelly. Hello, everybody, and welcome to. Man, I'm not sure which one of these. Which I haven't really been keeping track of how many of these we've been doing, but welcome to another episode of our Labs Open Office Hour, where you guys, the audience, get to kind of ask some questions, pick the brains of one of our Labs members. And this week we have, let me see, I think I point this way, Kelly Shipman. He is our resident sort of game dev, 3ds Max. You kind of seem to dabble in quite a bit of different things, right, Kelly?
Yeah,
Yeah.
that is correct.
Yeah, so this is always fun. I get to, especially the game dev stuff, because it's, somewhat personally interesting, but also just the crossover with like AI, and there's like a little bit of engineering and 3D modeling and stuff as well, and simulations and things, and it's pretty interesting stuff. So just in case for those who may be watching and don't know or listening later, go ahead and introduce yourself, your background, a little bit of what you have done and do, and that sort of thing.
Okay. So I'm Kelly Shipman. I am the newest labs technician. Been with Puget for about 3 years. Prior to coming to Puget, I worked in the game industry, did environment art for video games, did QA for software and hardware. So Puget kind of like brings that all together for me.
Right on. That's pretty cool. So you say environment art. What is that exactly?
So, like, I did not work on characters or anything like that. I only did buildings, little props, vegetation, that type of stuff.
Oh, okay. And is that kind of touch on like level design a little and stuff too?
Yeah. So level design would be the actual, like, how a player would move through the environment and like how they interact and stuff. Whereas the environment artist just creates the art assets. So they would actually provide us with a gray box. So just be like rough boxes that are just gray of like, this is a house. This is kind of the shape of the house, of the like inside. And then it'd be my job to then make that look believable to fit within the criteria of like, this is how much space a player needs to move through the area and everything.
Yeah. That's pretty cool. So, how has that experience then kind of applied to what you're doing for Puget Systems now?
So now I'll be testing 3D software packages such as Autodesk 3ds Max, Maya, perhaps a little Cinema 4D, those kind of things, which is the raw tool to create the assets. So that'll be the first step. And like creating the animations and all that stuff happens in those programs.
Oh.
You would then take those assets, put them into a game engine such as Unreal or Unity. So I'll be testing that side with like import times, compiling shaders, building lighting, all that kind of stuff.
Well, that'll be cool.
It's kind of that whole pipeline side of it.
Now, I imagine this has got to be a little difficult because as far as I'm aware, nobody's really ever done this sort of work before, like, or this sort of testing before. And so, like, I know you've kind of done a bit of a blog. You have that blog series going of following, kind of documenting the building process of this benchmark. But like, kind of give a little insight into that. Like, where do you even start? Like, I guess, there's questions about like, what do you decide to test? You mentioned like imports and things like that, but what's important?
Yeah. So that is probably the most difficult part of, well, depending on who you ask. The most difficult part of the labs process is like figuring out what needs to be tested. I get a lot of information from sales because they have customers who are saying, hey, this is what we do. This is the problem that we're having that we're looking to solve. How can you guys help us? So I get a lot of feedback from them on what should be tested.
Sure.
And then I also just spend a lot of time researching through forums, through even Twitter is a good resource for like people like, oh, I'm having this problem here or whatever, just to see what issues people are kind of experiencing that relate to the hardware. Like there's going to be issues with an importer doesn't work or whatever. If the tool doesn't work, that's not really our concern. It's like, hey, it's really slow doing this thing.
Okay.
That's where I'll look for that.
So, I suppose then, what has been the most, I suppose, sought after, so that you've encountered so far? Like, what is the biggest one that you're focused on?
Right now, the biggest thing is Unreal.
Hmm.
That's like the number one thing that sales is coming to me and being like, hey, we have customers that want to do this.
Hmm.
And it's a combination of building all of the shaders and compiling everything. Because it's not just like compiling the code, it's like building shaders, it's kind of complicated. And then building the lighting is like, even though it's real-time lighting in Unreal, it still computes a lot of information with like shadow maps and a bunch of other stuff.
Okay.
And that needs to be done before the player gets the game. It
Huh.
actually makes it more efficient. So it is real time, but it's also not real time.
So that's.
Um,
Oh,
yeah.
go ahead. Go ahead.
Oh, I was gonna say, so there's that stuff, the compiling, the building. Um, I've had customers looking at like trying to import like 500 textures into a material or into various materials. So like this bulk process of pulling all this data into Unreal to then create the materials. That's a long process.
Sure.
So there's that stuff, and then also the big thing with Unreal right now is the real time playback for film,
Oh,
TV, all that kind of stuff.
yeah.
We're getting a lot of people looking for like to be able to composite a a live actor into Unreal.
Oh, that's neat.
Mhm.
I have seen some that sort of like virtual production sort of thing. In
Yeah,
fact, you yourself were just shared a little
yeah.
clip of you'd like composited yourself behind a news desk sort of thing
Hmm.
in what was a basically a completely 3D environment, right?
Yep.
And was
Yeah, and
that
that was
go
all
ahead.
in Unreal real time. I could like move the camera around, and it was connected to my just my webcam, so the quality was pretty poor. Um, but it was kind of a proof of concept just to get it running.
So
Um, yeah.
I'm curious. So, in particular, regards to that little clip you showed, your your I guess video input, is
Hmm.
that technically two dimensional? Then is it just like a
Yes.
like essentially a cardboard cutout inside a 3D environment?
Yes.
Okay.
Yeah. So it was basically there was a 2D plane um, that was just sitting there that basically was being used as you can think of it as being used as the monitor of your
Okay.
computer. Is like
Sure.
it's a virtual monitor. And then I had to do some other stuff to like clip out the background and all that. It was a pretty janky setup because I had to use a special software that would cut the background out from
Oh
behind
yeah.
me, and then use that output into Unreal, capture that as the device to display on there, and then chroma key out that stuff, and then output from that to OBS to be able to record the video that I did.
Wow.
It was a little janky. It's not how it was designed. That scene was designed for Blackmagic
Okay.
cameras and capture cards. So Unreal actually has inputs and outputs for their stuff. So that way, if I
Mm.
connected a Blackmagic video camera, it would be able to see the SDI input, and then also be able to output to the Blackmagic capture card
Okay.
like directly.
That's neat. Um,
And
do you?
that allows for things like both Blackmagic and uh, AJA. I'm not sure if you pronounce it that way or not.
Oh, okay.
They actually, it's not just you can see the camera, it actually will sync frames with the camera and Unreal. So that
Oh.
way everything, there's no like jittering and frames are happening at the real time,
Oh, I see.
which is really nice.
That's pretty cool. How does So I think a lot of people are still very very caught up on ray tracing and RTX and things
Hmm.
like that. Is there I guess since Nvidia is pretty much the only ones who are in that game right now, is there any sense in, for one, I suppose, is there a way to test any sort of, is that something to test within the scope of your purview? And then is it worth doing since there's really only Nvidia and it's just buy the best Nvidia card or
It's definitely worth doing, because there's the, not just does it work, but like it is a significant performance hit on an NVIDIA video card to use ray tracing,
hmm
by quite a bit. So if you're using it for video, for like film and stuff, and you're using it with a live actor, especially, you want to maintain a certain frame rate at all times.
okay.
So you need to know how good of a card you can get away with.
I see.
For gaming, it's a little different because then you're like, as long as I can get 30 FPS, I'm fine. But for film video, you're looking at, maintaining 30, maybe 60 FPS at all times,
Okay.
zero dips, because then that'll
Right.
look terrible. And then you're probably outputting 4K or higher, and stuff like that. So it's definitely worth doing. That's going to be a little complicated because you're looking at Quadro offers a lot of help there,
Oh.
actually, especially with multiple cards. Quadro, you can also, like on the Mandalorian for their giant virtual
Oh
walls
yeah.
and stuff.
hmm
They have, I think they have 4 computers running that video wall.
Oh
So
wow.
each computer is responsible for certain sections of the wall. And then, so if using Quadro cards, there's a Quadro Sync card. Um, did I lose you guys?
No, no, I'm still here.
Okay. Uh,
I
I
just
thought
got
my,
that blank look for a second.
yeah. Um, so Quadro cards have a sync card that will then sync up the frames for all of those machines together. It actually has like a network cable that goes between all the machines.
Wow.
So that way there is no frame differences. Like as you're panning across that giant wall, all the frames are lined up perfectly between all these machines.
Okay. Yeah, because you don't want to
Um,
get like screen tear or anything,
right.
right?
Yeah. So you got all that kind of stuff that you can't do with like a GeForce card.
Okay.
Um, yeah.
That's interesting to know because like a lot of the stuff you do see, at least from a casual standpoint, a lot of that when it comes to ray tracing and things does come from a gaming standpoint, and so it's
Mhm.
interesting to know that. In fact, like I hadn't really realized that like it's there, it's in the name, right? The Quadro RTX cards, but like I suppose it hadn't really clicked to me like the application of it in the
Mhm.
Quadro sense. So that's really neat, and I like that you brought up the Mandalorian and what they're doing with like the those sort of it's almost like a hybrid virtual production environment,
Mhm.
and is I guess is that something we could test? How? Because I imagine they just threw money at that problem until they
Well,
just
yeah.
had, they just built the beefiest machines they possibly could. But I
Right.
see on Twitter as well. There's a handful of people working on more sort of DIY solutions in that sense, like sort
Mhm.
of draping a room in green, green screen material or whatnot, and or I think even the corridor guys were planning on trying to
Mhm.
do something similar with the bigger screens. Is that something interesting that we could look into, or something maybe you would want to try and like how
Yeah.
do you
So
and how would you even determine the performance for something like that?
yeah, there's 2 different ways of doing it. There's the Mandalorian way, which you need multiple high-end quadros to be able to sync together to run like, this whole giant wall in sync. And then there's the green screen method, which probably don't need multiple computers because it's just one environment, just basically one camera.
Right.
And so that'll be a little bit easier to test for us.
Okay.
At least that's my understanding as of right now. I haven't been able to dive that far into it yet.
Okay.
Maybe it's just as easy either way. I don't know. We'll find out. But yeah, that's the two different ways of tackling it. Is like, are you going to have Unreal output to a screen that you are then using a different camera to record that screen,
Mm-hmm.
or are you going to be looking at green screen and just rendering in Unreal that one thing, and compositing in Unreal and all that kind of stuff? There's
Yeah.
two different ways of doing it, and so we'll need to look at both of them because it's going to be different needs for
Sure.
each one. Because if you're just doing one system and using a green screen,
Mm-hmm.
you could probably get away with the GeForce, like a 2080 Ti, maybe two of them in with NVLink. I'm not sure if that'll make much of a difference. Probably
Sure.
would. Unreal is actually pretty good at multiple video cards.
Well, that's good to know.
So, um, yeah, they'll definitely be just completely different beasts, really.
Yeah. Does VR have an effect on any of this? Like, I know there's a gentleman. Oh bugger, I can't recall his name, but I see him come up on the Twitter that I follow a lot. And he ties in an HTC Vive with the
Mm-hmm.
green screen production thing, so that I guess it's so that it ties to the virtual camera within Unreal.
Mm-hmm.
And so is that, again, I'm asking a lot of questions about more like future looking things, but is like, are you going to get to play with a Vive and stuff in the future?
I hope so. I mean, we need to at least be able to do enough of it to see what it does, to see if I can then build a benchmark around it.
Sure.
Because you have to remember, once I create a benchmark for this, I have to be able to run that on 20 machines, or I guess we have 10 right now. It's going to be a few more in a little bit.
Yeah.
And some of them are like, they're set up in a server room. Like, how am I going to get a camera connected to that machine?
Mm-hmm.
And, so I'm hoping to find ways to simulate some of this stuff. Yeah, so that's the goal. But for VR, there's a couple different things going on. There's that stuff, which is using the hardware of the VR machine to just track movement. That
Okay.
shouldn't be too terribly taxing on the system beyond what it's already doing.
Sure.
And then there's the VR like headset, which that is more taxing because that's trying to maintain 90 FPS, I believe, is what most of them target.
Okay.
So you don't get
that.
motion sickness and and the basically two different monitors, and so that's taxing because it's trying to like maintain this high level of performance, whereas the other one is like just seeing where something is in the room.
Okay. Yeah.
Yeah, but I think I know who you're talking about. Cinematography Database is one on YouTube.
That's the one. Yeah.
Yeah. Been watching his stuff.
It's remarkable.
Yeah.
Just what he's been doing with what seems basically like duct tape and baling wire in a big way.
Yeah.
It's pretty cool.
Yeah. Well, that's how a lot of this stuff starts off. And then Unreal is very open to like seeing what people want to use their software for and then incorporating that into their stuff. Because Unreal used to be just a game engine, and now it's
Right.
used for film, for TV. Architectural visualization is really popular with Unreal.
That's right.
Like doing product demos in Unreal is really popular, like rendering out scenes and stuff.
Mm-hmm.
And even some machine learning is going on in Unreal. So like
That's interesting.
everybody, like every industry is looking at the software and like trying to see how they can use it because it's become so open and has so many different modules you can attach to it. Like there's official Blackmagic plugin so you can connect an SDI output video card or camera. Like who has that other than professional video people? But that's like an
Right.
official plugin. So yeah, it's grown well past just being a game engine.
Wow. So we do have a question from the chat from our good friend Sir Wade Nidestat. He says, "I'd love to hear more from Kelly about the challenges of the Unreal Engine 4 and slash live action video integration challenges, and what he thinks it will lead to or would like to see done using the tech."
Yeah, so that's going to be like we were talking about earlier. Okay, well, I guess it depends on if you want to talk about my challenges as a benchmark developer or the challenges of the industry using it.
Let's start with your personal challenges.
Personal challenges is, how do I set up cameras on all these computers that I then have to then benchmark? Like, is that something I need to do? If I wanted to simulate running a video wall where I need to have multiple computers with Quadro synced together, like, is that even feasible? Or are we just going to be like, yeah, you're going to need a Quadro 6000 on all these computers and the highest core CPU you can get. So there's that challenges for me. It's just going to be like, okay, how do I test this? Let alone test it on one system, but test it on a variety of CPUs and a variety of video cards.
Sure.
That's the biggest thing for me.
Yeah.
For the industry as a whole, the two different ways of doing it is the video walls, like the Mandalorian, that has the challenge of needs crazy hardware, like just top the line. Because to use Quadro syncing, you need a Quadro 4 or Quadro 5 or 6000.
Okay.
Which the Quadro 5000 is $2,000 each, I think.
Well, that's like top three, right? That's 5,
Yeah.
6, and 8. Right?
8, yeah. And what between 6 and 8 is how much RAM. They're the same,
Okay.
same processor inside. But then if you have just a giant scene with massive textures, you might need an 8000 to cover the RAM needs. So you need this massive system. For the green screen, you have, even if you do have the camera tracking in Unreal, so you can move it around and stuff, you have the problem of lighting, where you'd basically have to set up, which is what they do in movies right now when they're filming against a green screen, is they have to determine where they're going to put the studio lights,
Okay.
and what colors they're going to be and all that kind of stuff. So that way it's lighting the actors fairly consistent with what your scene is going to be in 3D.
Oh, sure.
So that's going to be, that's the biggest challenge that those guys face, is how do you light the actor to match the scene?
Wow.
That gets really complicated, because like you need it to be at least close. You can do a lot of color fixing in post, but not to the extent of like you have a bright light from the person's face, but the sun's behind them. Like
Sure.
you have to make sure that you're doing that close. Or if it's in a moving scene and there's like lights flashing by, like how do you do that in the studio?
Do you think it would be, I mean, and maybe we're not at this point, but I wonder, would it be possible then to, especially with something with as like ray tracing gets more advanced, would you be able to have a sort of virtual light, maybe sort of paint, you know what I'm trying to say? Maybe like within the 3D environment, the fake space, sort of like in a post-processing sort of way, exists that in that sense, so that maybe you can be a little sloppier with the real lights.
Yeah, I wouldn't be surprised, because I mean that's essentially what the video wall also provides, in addition to having the background to film from, is it gives light, like natural light, to the actors, because they're fully surrounded by the scene in this with these video screens. If there's a bright light in the scene in front of the actor that's behind the camera,
Right.
that light actually exists on that video wall. So
Even if it's not displayed.
Yeah, because they're rendering the entire scene regardless.
Got it.
They actually reduce the quality of the stuff that's not on screen.
Sure.
To probably save rendering performance, but then that still gives the natural lighting. So I could envision in a green screen scenario you could have like these massive LED panels
Mhm.
that have, not a high resolution for if you were contribute those LEDs to pixel,
Right.
but it'd be enough that you could alter the lights and stuff to make it, seem like you're passing by a tree or something, and kind of blocks momentarily and gives the right
Ah.
color of light or something. Like
Ooh.
that wouldn't be too difficult.
Oh, that'll be neat. That'll be
Yeah.
really cool. I think one of the neatest things coming from the advancements in Unreal, I think, is going to be this sort of virtual production,
Hmm.
and these sort of and the combination of either it like you were saying the kind of the two different ways of doing it. It's man, it's really neat. I'm
Hmm.
very excited. Um, um, oh dang it! I had a bit of a question, then I let it go. Let's. Oh, and I suppose just offhand, we did have a question from Twitch from Uro666. Do you know how much CPU RAM they were using in the systems for the real time rendering in The Mandalorian? You had
I
mentioned
have,
the Quadros,
yeah, I have
but
not been able to find any specs for what they used, but I would assume it was pretty beefy.
sure.
Just because uh, I would assume they're using very high resolution textures in a lot of them. So that
Okay.
means you're going to need a lot more RAM, and you're going to need a lot of like process power to move that stuff around. So I would guess at least 128 gigs, if not more, RAM, and possibly a Threadripper or something,
Sure.
or something higher end to support. I would not be surprised if each computer had two Quadros, probably
Sure.
RTX 6000s, and
Yeah.
then four systems combined.
Wow. Only four. I'm a little surprised to hear. So and you're sure like it was only just four systems.
That's what I heard was four,
Wow.
because
I
you have
would.
like a master that controls everything,
Uh huh.
and then the other ones. At least that's what they've. So, Mandalorian was not actually the first one to do this kind of stuff.
Oh, neat.
Like, Childish Gambino actually had a concert that was in a dome, that like was erected for him. That
What?
was it was projected onto the ceiling instead of having LED walls. It was the
Okay.
computers were projecting onto the ceiling, and it was like the full dome was covered. And they did the same thing with multiple computers using the QuadraSync cards to then sync them all up, and then there's this whole thing.
That's amazing.
Yeah, I'll find the
Wow.
video of it and send it to you.
Oh,
Um,
yeah, that'd be
yeah,
great.
so
'Cause that sounds. That's. I mean, that's kind of mind blowing. I know that. And like I'm pretty sure. I'm pretty sure we can talk about the Hollow Dome,
mhm.
by um, not
Yeah,
Jobs,
the
but Paul
Ballmer,
Allen, but the late
Paul
Paul
Allen, that's right.
Allen's
Yeah.
his little thing, um, a similar sort of concept where it's like a big dome thing that
Hmm.
they're doing a high resolution projection sort of
Hmm.
to make a 3D environment like that. That's amazing. That
Yeah.
is mind blowing. So I'm kind of getting mixed up because there's I'm very curious about I guess just what it is you're working on and all that kind of a thing. And so the benchmark is still being worked on. But I imagine
For
you've
Unreal.
been, yeah, yes.
Yeah, just starting.
Oh, okay.
I'm in the
Um,
research side of it right now.
I see. Do you have any sort of preliminary results?
No,
No.
no. I'm still researching because, so, like I was saying, that all these different industries use Unreal.
Hmm.
So it's going to end up being like a multidisciplinary project. So
Oh,
I'm going to
okay.
have to get Matt involved with some of the like how it works for film and all that kind of stuff, and then get
Oh,
William involved with how this works for engineering. Because I saw some stuff on Unreal about like using drones to then like do the 3D mapping of
okay.
like
Like the
some kind of,
photogrammetry
yeah,
for
some
a
photogrammetry stuff that
building or something.
can then import all that data directly into Unreal, so then you can
No
you know,
way.
go around it in a VR scenario. It's used for machine learning,
Mm-hmm.
so I'm going to have to get Don involved in how to get his stuff in, and yeah, it's
Oh
going to be
wow.
it'll be a bigger task, and so it'll be a lot of stuff that I'm going to be doing for the game dev side and 3D
Uh,
stuff, and then like also kind of leading them and helping them get their stuff
okay.
to
So
Unreal.
where are you starting then? To game
I'm
dev? Just
Yeah, I'm starting kind of game dev and the film stuff because that's just the majority of our customers have been
okay.
asking for that kind of stuff. And just researching what the needs are,
Yeah.
to know where to begin creating the benchmark.
I see. I see.
Yeah.
Right on. Let
So
me think.
before that, I've just finished 3ds Max. I finished the benchmark for that and did some
Oh.
CPU articles on that.
Oh, right on. That's awesome. Do you want to talk about that a little bit? Anything
Sure.
interesting coming out of that? Well, I suppose because I'm a little unfamiliar.
Mhm.
What is 3ds Max? What is it used for?
So 3ds Max is one of the like top of the 3D modeling and animation packages.
Okay.
Kind of the more popular ones right now are 3ds Max, Maya, and Unity. No,
Oh.
Blender.
Oh.
Sorry.
Oh. Okay. Okay.
I always mix up Unity and Blender in my head. So those are like the kind of the three big guys.
Okay.
So that's the one that I used the most when I was in the game industry. It was traditionally used by the game industry first, whereas Maya was traditionally used by film, and then
Oh.
Blender is kind of the newcomer.
Okay.
That's open source, so it's kind of not a lot of like professional like big business people are using that yet, but
Okay.
it's growing. Like it does some crazy stuff. So that was the beginning of it. Was Max was it was the cheaper one, and it was
Okay.
available on Windows first, so that was the one that game developers kind of latched onto first.
Sure.
Whereas Maya started on the it was on Unix.
Oh
Can't
wow.
remember the name of the computer that it was running on right now. It was the from Jurassic Park when the girl's like, "This is a Unix system. I know this," and
Oh
she's like,
yeah.
"It's like a 3D fly through of the file system."
Yeah.
Yeah, that was the 3D artist's computer. Like
Oh.
they just took that from the animation team and like stuck it on the set,
Oh, that's
and
funny.
that fly through file system that was real. Like that actually was on that system.
I thought
It
that
was
was a
like
goof. I didn't think
no,
that was legit at all.
no, it was
That's
like it's
awesome.
like it was like a free like download that you could get at the time to like make your file system do that. Like I don't think anyone ever used it in real, but like that was all real, and that was like I said that was the art's computer. They just like took that and put it on the set. And,
That's neat.
Mhm.
So for 3ds Max, anything? So I suppose since you've got it kind of complete, your
Mhm.
benchmark is the way you like it and you have it. What was the hardest part about, again, you have the whole documentation, the blog series that you did, but for anybody who hasn't been through that, what was the hardest part about all that?
For me, the hardest part was learning the programming.
Sure.
That was because like I come from an art degree.
Okay.
I'm somewhat technically minded, but not. I don't have programming experience, so that was a little challenging. But luckily, Max has a built-in scripting language that was
Oh,
actually
nice.
really easy to pick up on. So I was able to create the majority of the programming for the benchmark within 3D Studio Max. So it's basically
Oh.
just a script that runs and will output how fast each test was performed.
Oh, neat.
And then I used AutoIt to kind of make a wrapper around that to be able to install it, and for our benchmarking software to be able to like run it and all that kind of stuff. But as far as the results itself, nothing terribly surprising.
Yeah.
So 3D Studio Max is to overgeneralize is the like 3D modelers tool, whereas Maya is like the 3D animators tool.
Oh, okay.
Um, Again, that's super overgeneralized, but um,
One builds the
Max is
puppet, the other one pulls the strings.
exactly. So these two Max is used a lot for environment art. It's used a lot in the architecture side of things because it's really good at making models,
Okay.
especially like square models, you know, not like
Buildings and
characters.
stuff.
Yeah. So I had to kind of like look at how that is being utilized. How do modeling tasks work? And modeling is very difficult to measure performance on because like it happens in an instant, right? Like you move a polygon or something, it's really quick. Once
Okay.
you start getting millions and millions of polygons and you do a modifier onto all those polygons, it
Hmm.
starts to slow down just a little bit. And a lot of the modeling frustrations I found online were just like it's just not responsive, it's not snappy, it's
Huh.
how do I make it work faster? Because like if you get enough stuff going on, you'd click on like select an object and it would like half second later it would finally select, and you'd move something and it'd be like this lag behind of what you're trying to
Oh.
do. So trying to figure out how to test something that doesn't feel right is a little
Yeah.
difficult. So I kind of had to like exaggerate a lot of things beyond what any normal person would probably do,
Sure.
just to be able to give it enough time to be able to get consistent results.
Wow.
So that was probably the hardest part.
What kind of models that so you're saying you had to kind of bring things to an extreme. So like what sort of a thing are you using then in order to test like how much do you have to throw at the software in order to get that sort of like I suppose laggy movement and jittery.
Um, Tens of millions of polygons, like just
Millions.
huge amount of stuff, which
Wow.
is not unheard of. And so Oro
Okay.
in the chat is saying that you
Yeah.
can do animations in 3ds Max too. Yes,
Yeah.
that's true.
That's
In fact, Avatar, James Cameron's Avatar,
Oh yeah.
that was made in 3ds Max.
No way.
Yeah. So like when I say that, I was trying to say that those are over generalized statements because like full on movies have been made in 3ds Max and in Maya, even though it's primarily Maya.
Sure.
And games have been made with Maya, even though game developers traditionally have used Max. Like it's not a cut and dry. It's trying to
Sure.
be very overly generalizing that kind of stuff.
Okay.
But if you ask Sir Wade, he'd probably tell you not to animate in 3ds Max if you could. But he might be biased. I don't know.
That's pretty cool. Man, I'm shocked to know how. I guess it just kind of. I guess personally at least, and I'm sure some of the people watching have just kind of assumed that, like you said, Avatar was all done in 3ds Max. I would have
Mhm.
thought that kind of a thing would have been more of like, I guess, After Effects and things like that. But I guess I just have a misunderstanding of the crossover of all this stuff.
Yeah.
Because yeah, I assume that visual effects or CGI sort of stuff is done in either After Effects or like Cinema 4D or something like that. And I
Mhm.
guess it's it, it's everywhere. There's all kinds of different
Yeah.
things. Like the car might be modeled in Maya, but then the physics of it is done in something else.
Mhm.
Or, if it crashes into something, and then the particles are done in something else. And
Yep.
and I suppose I'm only just now realizing it as you were talking about how you're going to have to work with the other members of labs to
Mhm.
to make this Unreal thing work, because it's got its fingers into all these different industries, and like
Right.
it's amazing, and wow, it's just so much bigger than I suppose you may have assumed.
Right. Well, even things like there's a behind the scenes of was it, I think Adventures of Tintin, Rin Tin Tin, something like that. It was a CG
Oh,
movie that came out a few years ago.
yeah.
There's a behind the scenes where there's a certain scene in there that there's a very long like one take of like them like rushing down the mountain in this car or something. I can't remember exactly what was happening, but
Okay.
it's a very long, seemingly one take shot. It's all done in 3D. But then you watch the behind the scenes, they basically kind of blocked out the whole scene, kind of like you would do with like, storyboard, but in 3D, animated the camera movement, and then took that camera movement and then imported it into a whole bunch of different scenes. So like one scene is just the water, another scene is just the car, another scene is just this thing. And that way each section can be worked on independently,
Uh-huh.
and then they just composite everything together at the end. So you
Wow.
don't have to do the entire screen that you see on a movie in one 3D scene. You just do it in smaller chunks and then composite it all together, but you can like sync them up by using the same camera movement.
Wow.
Yeah. Like that's,
That's neat.
yeah, you would probably never want to do the entire scene because like if one little thing goes wrong, it's a lot of performance, like a lot of rendering cycles to go into that.
Sure.
And
Sure.
so if you're like, oh man, that water doesn't look good, you don't have to render the entire frame. You just like, okay, let's go re-render that water and put that water in instead. And
Right. Huh. It seems so simple when you put it that way. It like kind of one of those like, well, duh. But at
yeah,
the same time, like before that, you kind of, like I said, you just kind of assume, well, yeah, it's gonna be that
yeah.
whole scene at once, and then, huh? That's
I mean,
really
besides,
cool.
if it was the whole scene, you have, 300 animators or 3D artists of some sort all
Right.
contributing to that file. Like, how are they gonna all contribute to that scene? They can't work on it together. But
Right.
no, they're all doing their own parts, or one team is doing their thing, and then they just mash it all
Smoosh it
together
all
at the
together.
end.
That's amazing. How, man?
And the same thing goes with, like you're talking about, Cinema 4D. Houdini's another one for
Mhm.
like particle type stuff,
Yeah.
and a bunch of other software like After Effects, whatever. So like you might have the 3D scene, but then you're going to give it to an After Effects artist who's then going to do their stuff on top of that, and then another person's going to do a color grading and in DaVinci or something. And
That's cool.
so yeah, everybody will cooperate together to get it done.
Yeah. That's neat. So to kind of swing back to Unreal.
Hmm.
There's terms that I've heard tossed around sometimes, either reading some of your articles. I remember like an early one you talked about when RTX first came out. But I just to kind of get a better insight into how the software works and stuff. What you hear about baked lighting?
Hmm.
What is that?
So that is it's still actually used even in real time lighting scenarios.
Okay.
But baked lighting is basically, so you'd set up, say, my room here, and I have a couple can lights up there.
Hmm.
Instead of like having to every frame trace where that ray is going to go, that ray of light, and how it's going to hit the wall, you would do that ahead of time.
Okay.
So the engine will look at the scene, see all the lights are, determine how they're going to project their light onto the scene, and then it'll actually take all the 3D models you have
Hmm.
and create a new texture that will go on top of them,
Oh,
which is basically just like in Photoshop doing a multiply layer of like
sure.
it's white and black with like this is bright, this is dark, and then that texture just overlays it to make it look like there's light there, but it's just like another texture laying on top of everything.
Wow.
So that's what it's computing, is like seeing where the light's going to go, baking a new texture, and then applying that texture to the scene.
That's interesting. It's also, I'm always curious about where some of these terms come from. Like why are you baking the light? Like why is
That's a good
that the
question.
term?
Yeah.
I'm curious oftentimes about where some, and I'm sure there's some it's probably some sort of like cell animation where they literally were baking some sort of like plastic cell to
Yeah.
make sure that it looks just right or something.
Could be. Who knows? Yeah.
Yeah, there tends to be a low tech explanation for some of these terms as we've evolved through
Yep.
different technologies and stuff.
For
Like,
sure.
yeah, somebody was actually baking the paint or something
Right.
to make sure it looks right.
Yeah.
Let's see. Let's see if we have any questions in the chat. It's a big fan. Let's see. It's less graphically expensive than real-time rendering. Yeah, that makes sense. Yeah, because if it's, well, I mean, that's been a big issue. Like, I remember ray tracing being talked about in the mid 90s, and you could do it then, but it would take 30 seconds for one frame to know where all the light beams were going to go and stuff. Like, we've been able to do it in a small sense, but now we've gotten to a point where we can do it somewhat real time. So
well, and it's less expensive because, so if you have, like, we've had shadow casting lights in games for years. Like, I mean, Morrowind had shadow casting lights.
wow.
So, like, what happens there is basically it's a very small section of that, like, baked lighting, because that light can only affect a certain area.
Sure.
And it's basically, we'll just compute a, like, basically an alpha, like a silhouette of whatever's moving through that light. But it has to do that every frame on every polygon that is within its radius. So if you have too many of those shadow casting lights, it's doing it so much that it just gets too expensive. That's why a lot of times you don't see too many shadow casting lights within one scene.
I see.
If it seems like this, like it's really common to walk through a game and be like, oh, I'm walking through a shadow casting light, but this light right here is not casting a shadow, and it's like next to that one. It's because they determined like that one wasn't important enough to worry about. So this one gets the priority so it can have the effect and not impact performance too much.
I see. So
because it basically has to redraw the geometry multiple times for every light that you put in there. And
yeah, that's gonna bog you down quite a bit.
Yeah.
We have another question. This one's actually coming from Twitter, from our Periscope viewer, Mark Brandt. He says, he's asking, how big of a deal is Ampere? Ampere, which I think is Nvidia's next step graphics cards. I know we don't have any like samples or anything, but I suppose it's more of an opinion question.
Well, I don't pay a whole lot of attention to the rumor stuff. And right now there's not a lot of information on it. So I don't have much to say about Ampere because I have no idea. Like at this point, it could be anything. I don't know.
Are you hopeful?
I'm always hopeful. Like,
Sure.
I mean, as just a general gearhead, like I want something really cool.
Yeah.
Like I was excited for real-time ray tracing more so than most gamers were when the RTX first came out.
Yeah.
But I actually didn't think it was going to go into games right away, but whatever.
Sure. And yeah, I suppose that kind of does make a bigger deal from your point of view as an environment artist and whatnot, right?
Mm-hmm.
Yeah.
Because, well, for the game industry, with the real-time lighting, so it has a huge potential to increase or to make the production pipeline faster, because you don't have to then bake those lighting. You don't have to like worry about creating a cube map that makes a reflection. The engine just takes care of it for you, and more realistically than you can.
Nice.
So that's the goal. The problem in the game industry is that you have to support that technology and the old technology at the same time. So you're not saving any time. In fact, now you have to then author it to work for the old style and the new style. Like I've told this before at work, but when they announced RTX, they announced it at SIGGRAPH for the Quadro cards. That's where they announced it first. And I honestly thought at the time that was going to be Quadro's selling point, was they had real-time ray tracing. I did not expect them to put it onto GeForce
Oh.
because I was like, yeah, it's gonna be cool, but it's not gonna give much performance.
Hmm.
And if you look at most games that do use real-time ray tracing, like you're doing good if you hit 60 FPS.
Yeah. Right.
On a 2080 Ti, like that's a lot of money to put onto that to get that little of performance.
Sure.
But that's good enough for film if you're trying to get a film at 30 FPS. Like,
Oh.
so I
Yeah,
thought
that
that was
makes
going to
sense.
be kind of their why you'd want to buy a Quadro.
Sure.
But then they put it on GeForce, and now here we
Yeah.
are.
And I mean, I feel like this may nowadays it's kind of a hashed topic, but it's like it did seem premature to give it to the games industry when there was like 5 games that anybody even knew. You know, the developers didn't even have the opportunity to really work with it yet. It seemed very, well, half baked in a way. Like I feel like it should have, that would have been a better step, was to
Mhm.
trickle it down that way.
Right. Yeah, it's one of those things that like the Nvidia's, well, even AMD knows this is the next step is ray tracing. They've already
Sure.
been AMD's been showing off their ray tracing stuff for a while as well. They haven't talked about if it's like specific hardware like Nvidia has or not, but everyone knows real-time ray tracing is the next step.
Sure.
So Nvidia has the technology, and they have to decide, okay, how do we get this out to people? Like at some point, no one's going to develop it if it's not available to develop for.
Sure.
But like, how are we going to put it out there if no one has developed anything for it? So like, it's the chicken and the egg thing. Like something has to start it.
Right.
So I think Nvidia kind of just like took the bullet almost.
Yeah.
Like, yeah, this is, it's going to look good, but also not look good at first.
Sure.
But it's going to move the industry forward. So maybe that's a little too optimistic on my part. I don't know.
Hey,
But
I
like
like it.
at some point, someone had to put the hardware out there so that someone could develop software for it.
Sure.
Um,
Yeah.
So they kind of just did it. You can argue if it was too early or not. That's a whole different debate. But like it had to start at some point. So
Yeah. All right, we have another question from the chat. From this one's from YouTube. Tan May asks, what additional consideration are made to adopt or use DLSS while making any game? So, what is DLSS? Do you recognize?
DLSS is deep learning super sampling.
Okay.
It's basically anti-aliasing,
Okay.
but machine learning.
Oh.
Machine learning driven. So instead of rendering out your 1080p scene, and then for each frame, after it renders out that information, it then has to look at all the lines and everything in the scene and determine, okay, this pixel, should that be halfway between these two pixels, and then like blur out the edges to make a crisp line so you don't have the jaggies.
Okay.
So that happens every frame with regular anti-aliasing. DLSS, basically, Nvidia has all these games just running through their machines, and it like is comparing a 4K or higher resolution render of that scene with like a 720p resolution. And then it just sits there and machine learning compares them back and forth to say, then teach the model to be like, okay, the 720p render, if it was to scale up to 1440p, this is how it's going to look, because we have done the machine learning to like, this is what the goal is, and
Right.
it knows. So DLSS is like that version of anti-aliasing. It's
Okay.
pretty
Okay.
crazy. So what considerations go into that?
Is that
From
something
my-
that happens on the game dev side, or is that an after? Like, is that something that happens when I turn the setting on, or is that work that has to be done during development?
So it's work that's done beforehand, because it's basically built into like the driver software to
Okay.
like know how to do these computations. So Nvidia is running a lot of stuff already, and it doesn't have to be specific to your game.
Okay.
It's just learning how to, when it sees these shapes, how it then translates it up.
Oh,
I mean, we'd have to
okay.
ask Don more about machine learning, exactly how it's happening
Sure.
in the
Sure.
background. But I don't think that on the developer side they have to put a whole lot of thought into it, because
Okay.
it's handled by Nvidia and the driver.
Wow.
Because you're still going to have, it's like a checkbox. You have DLSS, um, TAA, temporal anti-aliasing,
Mm-hmm.
and then other
X4,
anti-aliasing.
X8. Yeah.
Yeah, they have all these other options. So
Yeah.
the user can swap between them. But probably the biggest consideration, I guess, would be like, is NVIDIA supporting your game or not? I don't
Oh,
know.
and so this DLSS is exclusive to Nvidia.
Hmm.
It's their fancy thing.
Yep.
Okay.
It requires
Wow.
RTX video cards.
Oh wow. Okay.
Yeah.
That's neat. That's I had, thinking back on it now. Like anti-aliasing has always been an interesting because you see different kinds of
Hmm.
AA in games, and it's is it just like a different way of calculating how to smooth the jaggies?
Yep.
Okay.
Yeah. Basically, each is just different way of calculating, and each has a different plus or minus to it. And it's kind of, sometimes it depends on which game, what kind of graphics they have, what is
Yeah.
going to work better, what your performance can handle. The DLSS is actually very, very efficient now.
Mm.
We're on like version 3, I think, right
Okay.
now, DLSS 3.0. It's gotten a lot better since the release of RTX cards. And it, like, you can basically run the game at 720p and upsample it to 1440 and not really see the difference, but you get the performance benefit of running it at 720p.
Ooh,
So it's pretty impressive.
that's cool.
That's essentially what's doing in the background. You tell the game you want 1440p, but then you check DLSS and it actually renders it lower, but then helps you get better performance that way.
Oh, that's neat.
Yeah.
Huh. Sir Wade asks, is there anything in the upcoming benchmark you're most excited to test, or any curiosities you have?
So there's the film stuff we already talked about, because that's like the hot topic right now.
Sure.
Is how does all that stuff work? And then I'm also interested to see like deeper dive into how we can touch on other industries, not just game and film.
Sure.
Because I know a lot of other industries are. I'm really interested to see how it works for architectural visualization, because that, like, the renders that they put out are super high definition, like amazing lighting, some of the most realistic renders, but it's running in real time. So I'm really interested to see how ArcVis works. Yeah, mainly
Yeah.
interested to see how all the other industries play into it.
I have to agree that yeah, the architecture side of it is really exciting to me too, because like um, I just like the idea of like, say you want to build a new house,
Hmm.
and you could potentially walk around your new house without it even being built yet.
Hmm.
And say, oh, I want different countertops, or like maybe that
Yep.
window looks funny over there, so we can just shift it this, and or cars even, like
Hmm.
in the design stage of a vehicle, you can all the physics work involved, all the you can figure out
Hmm.
how this is going to move and bounce and shine, and like textures, or like I want a different dash, or I just
Yeah.
I think that the it's almost like a rapid prototyping sort of thing,
Hmm.
and the potential there is going to be very exciting, very cool to see.
Yeah,
I think.
for sure.
Yeah. Uh, let's see. Let's see. We're almost at our hour, so if you guys have any other questions, please do ask right now. Get them in here. We'll wait another minute or two. Is there anything, while we wait for a few questions to come in? Is there anything you'd like to mention, shout out, or talk about in your space and place?
Me?
Yeah, you.
Um, Nothing specific, but if anyone does have like, hey, I want to see this in a Unreal benchmark, let me know and
Yeah.
I'll see if I can figure it out.
Yeah.
Um,
Are you in communication with anybody with Unreal? Like, I imagine the developers of the, of the software may have some insight into what should be tested.
Not yet. Um, our understanding is that they're a little closed off.
Okay.
But what we've seen in the past with Adobe and other people is that once we start getting the benchmarks out there and people start seeing what it actually does, then they're more interested in talking. So
Okay.
at this point, we'll kind of, put the word out there, see if they want to talk, and then start working, and then maybe our work will speak for itself.
Yeah. So is your 3ds Max benchmark available for download and running at home?
Not yet. So I wrote the code for that benchmark. And as I said before, I have an art degree.
Sure.
So it's a little messy. The goal is to make it publicly available.
Okay.
It needs some kind of cleanup and stuff, at least for it to be able to upload results to our website like our Adobe benchmarks do.
Okay.
I had some problems with my FPS test, like viewport frames performance, to be able to get that to record properly and behave properly in a script. So it's not the cleanest, but I probably could share it with people because that's the goal. There's nothing in it that is like proprietary, super secret stuff. It's just all, especially the Max script. The biggest downside to it is that it's probably 6 gigs, I think, just to have enough stuff to test.
Right.
It's like I have the saving and loading scene, and to be able to run like the frames per second, and the size of a scene is directly related to how many polygons are in there.
Sure.
So to get that scene by itself is 4 gigs.
Wow.
So yeah, it's just a big file.
Yeah.
But yeah, that's the goal, is to make it publicly available. I might do a beta release at some point that like it won't upload to us results or something, and just to get people's feedback on stuff.
Okay. So soon TM.
Yeah, soon.
Yeah.
Yeah.
Yeah. Uro says he has Max files that would dwarf your benchmark.
Oh, I don't doubt it. It's really not that hard to get a file to be 4 gigs. Like it's pretty easy.
Okay. Well, all right. I guess since we're 3 minutes over the hour, we'll call it good here. I want to say thank you, Kelly, for taking time out of the day to join us on this Friday's Labs Open Office Hour. And I hope, and thank you, audience, as well, for joining us in this. We do this sort of thing Wednesdays and Fridays at 1 o'clock Pacific Standard Time. Wednesdays, we bring in outside industry experts to talk about their workflow and software and trials and tips and all that good stuff. And then on Fridays, we have members of our team basically do the same kind of thing, but just talking about more internal, the benchmarks and maybe future-looking things and that sort of a deal. So follow us, YouTube, Twitch, Facebook, Twitter, Instagram, all that social media stuff. Kelly, you are available where?
Twitter.
Okay.
Yeah.
At KW Shipman, I believe.
Yes.
Yes. So yeah, follow Kelly. He posts all the articles and things like that as well, and helps answer some questions out there on the social media times as well. So mark your calendars. Wednesdays, Fridays, 1 p.m. And I think that's it. So thank you very much, and we'll see you next time.
Yeah.